Hey students, welcome back to lecture series on Z transform. For more videos, you can check in my I button over here or downside here in my description box. You will get the complete playlist for Z transform, Fourier transform, and first unit linear differential equation with the constant coefficient. You will get the complete playlist there. Okay, so in my today's video, I'm gonna explain to you all some of the questions from Z transform. Okay, based on the property that we learned in our previous lecture. Okay, so let's go for finding the Z transform for some K. Okay, if you have some only K present in our sequence. Okay, so how can we find the Z transform for that sequence? Okay, now see that actually we directly cannot find the Z transform for K because we have to advance this sequence in some standard form, so then only it is possible. Okay, and we know that one more thing, Z transform of K into 1 raised to K. Okay, 1 raised to K means 1 to the power any number. 1 to the power any number, it always remain 1, and 1 multiplied by K, it always goes to K. So that's why I written Z transform of K into 1 raised to K. Okay, as we have one standard property that Z transform of K into f of K can be written as minus Z into derivative of f of Z. Okay, yes, similar example I solved in my previous lecture, so you can see in my previous playlist there. Okay, yes, so let's get start this solution. Okay, so how can we write this one? Let me write one standard property that we have learned in our previous lecture. Okay, so we want this example solution. Okay, so we know that Z transform of K into f of K. We know that Z transform of K into f of K can be written as minus Z into d by dz of f of Z. Okay, so we write Z transform of K into f of K as minus Z into d by z dz of f of Z. Okay, so whenever a sequence Z transform of a sequence which is equal to f of Z, then we write this property. Okay, so I'm going to write this one. I'm going to write this one with compared to this. Okay, so K it is here as it is. F of K, we have given f of K as 1 raised to K. Not given, that means we build this one. Okay, f of K as a 1 raised to K. Okay, and we want the f of Z here. F of Z means Z transform of f of K. F of Z is a Z transform of f of K. So Z transform of f of K, okay, it also written as f of Z. Okay, Z transform of f of K, it also written as f of Z. Okay, yes, and it can be written as, okay, Z transform of f of K means 1 raised to K. Okay, 1 raised to K, and we have condition on a K which is K greater than 0. K need to be a bigger 0. Okay, that means here that condition comes as K greater than 0. So if K greater than 0 here. Okay, and we know that Z of A raised to K, Z transform of A raised to K, when K greater equals 0, we write Z upon Z minus A. Okay, Z upon Z minus A, and modulus of Z greater than modulus of A. Okay, this is the actual condition we have over here. Okay, yes, we are going to apply this Z transform of 1 raised to K when K greater than 0. Z upon Z minus A. Okay, Z upon Z minus A. What is the value for A? A which is 1. Okay, yes, Z upon Z minus 1. So this one is actually the value for f of Z. Okay, this one is actually value for f of Z, which is the Z transform of f of K. Okay, and we want the derivative of f of Z. Now let's find out the d by dz of f of Z here itself. Okay, so d by dz of f of Z can be written as d by dz of Z upon Z minus 1. Okay, so for solving this differentiation, guys, you can apply quotient rule for the differentiation. Okay, and d by dx of u upon phi can be written as phi into derivative of u minus u into derivative of phi divided by phi square. Okay, apply this rule over here and you will get the required differentiation. Okay, so v, what is the v? Z minus 1. Okay, Z minus 1, phi as it is, derivative of u, Z with respect to Z, which gives us the 1, minus u as it is, Z, what is the u? We have Z here as it is. Okay, and derivative of phi, Z minus 1 with respect to Z, which gives us the value 1. Okay, upon phi square. Phi square means Z minus 1 bracket square. Okay, yes, this one is the derivative. Now see that minus z plus z can be cancelled, so we left here the value of minus 1 upon z minus 1 bracket square. Okay, yes, so we have here minus 1 upon z minus 1 bracket square. This is the value for d by dz of f of z. Okay, this is the value for d by dz of f of z, which is a minus 1 upon z minus 1 bracket square. Okay, so but actually what we want here, we want the z transform of k into f of k, which is a minus z into d by z dz of f of z. Put all these values over here in this sequence. Okay, so you will get the required answer. Okay, yes, so what is the z transform of k into f of k? Means z transform of k into 1 raised to k. Okay, I'm going to write here z transform of k into, okay, z transform of k into 1 raised to k when k greater equal 0. Okay, so I'm going to write k greater, this one is a k greater equal to 0. Okay, z transform of k into 1 raised to k when k greater equal to 0 can be written as minus z multiplied by d by dz of f of z. So we write multiplied by minus 1 upon z minus 1 bracket square. Okay, yeah, this one is the actual value. Okay, now see that this minus gives us the value plus, so we write it's a z transform, or z transform is a z upon z minus 1 bracket square. Okay, and that is only the solution, guys. Okay, so we just want the z transform of any k. Okay, z transform of any k. Okay, when k greater than 0, we found this z transform over here. Okay, it's way easier, guys. Don't have anything, you can solve it very easily. Yes, so I want you all to solve some of the examples based on this property. Okay, let me write this example over here. You can take it for your homework. So see, guys, I added some of the example here. Okay, so first example here, k into a raised to minus ak, and say transform of k plus 1 a raised to k greater equal 0. So take this example for your homework, try it and tell me the answer in my comment section. So even after, if you found anything difficult, guys, let me know in my comment section. Okay, I will come up with the similar videos. And guys, you will get the entire playlist for all the z transform properties. Okay, in my description box. Refer it for your understanding. Note all these properties, note it down and prepare it well. Okay, as your in-sem exam it is coming, take this one seriously, because similar type of questions they are coming to your exam. Okay, so we need to be careful about this property. I hope you all have understood my today's entire lecture. Okay, so remaining part we go for our next lecture. It is only the left here one last property. We go for that property in our next lecture. Okay, so that's it here for our today's lecture. So thank you, guys. Thank you here for my today's lecture.